In section 7.2, we want to continue to find the values of the trig functions for acute angles. If you do a quick mental review in your head, and you remember SO, CA, TOA, remember that sine is equal to opposite divided by hypotenuse. Cosine is equal to adjacent divided by hypotenuse. And tangent is equal to opposite divided by adjacent. And then remember that the other three kind of are the opposite of these three. And so remember we talked about secant starts with S, and its reciprocal function, which is cosecant, starts with a C. Cosecant is equal to hypotenuse over opposite because it is secant flipped upside down. Cosine starts with a C, so its reciprocal starts with an S, and so secant is equal to hypotenuse over adjacent, and then tan goes with cotan, and cotan is equal to adjacent over opposite. Because these are so simple, because we're only dealing with three sides of a triangle, there are lots of relationships between these different trigonometric functions. So, for example, I could take the sine of an angle A, and I could divide it by the cosine of that same angle. If we look above, we know that sine is equal to opposite over hypotenuse. And I want to divide that by cosine, which is adjacent over hypotenuse. If you remember that you divide fractions by inverting and then multiplying, remember the numerator stays the same. We're going to change the division bar to a multiplication, and then we're going to take adjacent over hypotenuse, and we're going to flip it over. So we get hypotenuse over adjacent. The two hypotenuses cancel, and so we end up with opposite over adjacent, and you should recognize that as one of these guys up here, right? Opposite over adjacent is tangent. And so that gives us our first trig identity. And that identity says that the sine of angle A divided by the cosine of angle A is equal to the tangent of angle A. It is also the case that the sine of A is equal to 1 over its reciprocal, or 1 over the cosecant of A. The reverse of that is also true. The cosecant of A is equal to 1 over the sine of A. Cosine of A is going to equal 1 over, take a minute to think about it, what's the reciprocal of cosine? Go back up here. And the reciprocal of cosine is secant. So cosine is equal to 1 over secant. And secant is equal to 1 over cosine. And then that same thing is true for tangent and cotangent. So the tangent of A is equal to 1 over the cotangent of A. And the cotangent of A is equal to 1 over tangent of A. I'll just leave that sit here for a minute. Might be a good place for you to pause and get. In this example, this is example 2, This is from section 7.2 in the Green Book. Remember that there are copies of the Green Book on the shelf in the back of the room. You can also find a link in Schoology to a document called Chapter 7 All, and you can find this in there as well. So what we want to do in the second example is we were given sine and cosine, and we want to find the other four values. So this problem tells us that sine is equal to square root of 5 over 5, and cosine is equal to 2 over the square root 5. So we could figure this out by drawing our triangle and placing our opposite and our hypotenuse, but we could also use our identities, right? So you can see that they did that here. They said, hey, if I want to find tangent, remember that tangent is equal to sine divided by cosine. So they took the sine from up above, right? They took square root 5 over 5 and put it in the numerator. And then they took 2 root 5 over 5 and put that in the denominator. And they threw magic at it. They didn't really show us what they did here. So let's take a minute to look at that. I'm going to take the square root of 5 over 5. And in order to do this division, I'm going to multiply by the reciprocal of this. So the 5 goes to the top, and the 2 root 5 goes on the bottom. The 5's cancel, the root 5's cancel, and that leaves me with a half. If I want to find cotangent, remember that that is the reciprocal of tangent. So we just found out that tangent was 1/2. So cotangent is going to be 2 over 1, or just 2. Cosecant is the reciprocal of sine. And so since our sine is square root 5 over 5, we're going to take the reciprocal of that, and we'll have 5 over root 5. Sometimes MyMathLab asks you to rationalize this, right? So I'm going to pause for a minute. There it is. Never mind. Okay, so what that means is you want to multiply this by the square root of 5 over the square root of 5. I think we've done this before. This one will have 5 times root 5 over 5, because remember square root 5 times square root 5 is just 5. These 5 will cancel, and that'll end up being root 5. And then finally, we want to find secant. Secant is the reciprocal of cosine. Since our cosine was 2 root 5 over 5, our cosecant will be the reciprocal of that, so 5 over 2 root 5. Again, we're going to rationalize the denominator. That gives us 5 root 5 on the top. It gives us 2 times 5 on the bottom. The 5's cancel, and we end up with root 5 over 2. The next 3 identities that we want to look at are called the Pythagorean identities because they come from the Pythagorean theorem. If you look at this triangle over here, it has one side A equal to A, it has a side equal to B, and it has a side C. And so, of course, A squared plus B squared equals C squared. If I divide this, they switched A squared and B squared. It doesn't really matter. But if I divide this whole thing by C squared, I have B squared plus A squared equals C squared. And I divide everything by C squared. I get B squared over C squared plus A squared over C squared equals 1, because C squared over C squared is just 1. Right, so here I'm going to kind of factor out the squared. So this is going to be b over c squared. And this is going to be a over c squared equals 1. Okay, so now let's think about this b over c. And let's go back over here and look at our angle, right? B is the opposite and C is the hypotenuse. So the sine of theta is equal to B over C. So I'm going to do a replacement. I'm going to come back over here, and where I have B over C, I'm going to put the sine of theta. The same thing is going to happen with A over C. If I come back over here to my picture, you'll see that A is the adjacent and C is the hypotenuse. And so this becomes the cosine of theta squared. And that's equal to 1. And then because mathematicians are lazy, they rewrite this as the sine squared of theta plus the cosine squared of theta equals 1. You can do similar manipulations and find the other two Pythagorean identities, which say that the tangent squared of theta plus 1 is equal secant squared, and the cotangent squared of theta plus 1 is also equal to cosecant squared. And we'll look at how to use these in a couple of examples. So if you look at example A right here, we've got the tangent of 20 squared minus the sine of 20 over the cosine of 20. And the problem wants us to find an exact value, which means it doesn't want us to use our calculator. Hopefully you recognize that sine squared over cosine squared, I'm sorry, not squared, but sine over cosine is tangent. So the sine of a 20-degree angle over the cosine of the 20-degree angle, this piece is just equal to the tangent of 20. So I've got the tangent of 20 degrees minus the tangent of 20 degrees, which is 0. Second one is a little trickier. We have to recognize right here an application of one of our identities. 1 over secant squared. Remember, let's go back up. Can we find 1 over secant squared is not here in their identities. Then in our notes we took a minute ago, remember that we said that cosine of theta was equal to 1 over secant of theta. So the same thing is true, that the cosine squared of theta is equal to 1 over the secant squared of theta. So 1 over secant squared here becomes cosine squared of pi over 12. So sine squared of pi over 12 minus cosine squared of pi over 12. That's my Pythagorean identity. Whoops, that's, oh, wait a minute, that wasn't a minus, that was a plus. My Pythagorean identity said that whole thing is just equal to 1. I think we have already done problems like this example. If the sine of theta is 1/3 and theta is an acute angle, we want to find the values of all the other 5 functions for theta. So I'm going to move over here. Sine of theta equals 1/3. Remember that sine is opposite over hypotenuse. So let's draw a triangle. If this is theta, then theta's opposite is going to be 1, and theta's hypotenuse is going to be 3. So I could use the Pythagorean theorem to find this side. So my hypotenuse is 3. So 3 squared is going to equal 1 squared plus this other side. I'm just going to call that x squared. So it's going to give me 9 equals 1 plus x squared. Subtract 1 from both sides. 8 equals x squared. Square root both sides, and I get the square root of 8 is equal to x. Now, a couple people have gotten the lesson on how to simplify this. We can rewrite the square root of 8 with 2 parts. 8 is equal to 4 times 2. And 4 is a perfect square. So if I square root it, I get 2. And so this missing side right here is equal to 2 root 2. So now that I have the 3 sides of my triangle, I can use them to find cosine, to find tangent, to find cosecant, to find secant, and to find cotangent. Right? Cosine is adjacent, which is 2 root 2, over the hypotenuse, which is 3. Tangent is opposite, which is 1, over adjacent, which is 2 root 2. And then I need a little bit more space here. Cosecant is the reciprocal of sine. So cosecant is going to be 3 over 1, or just 3. Secant is the reciprocal of cosine. So that's going to be 3 over 2 root 2. If you're doing this on MyMathLab, it might make you rationalize the denominator, which means we multiply by this root. That's going to give us 3 root 2 over 2 times root 2 times root 2 is just 2. So this is 3 root 2 over 4. And then cotangent is the reciprocal of tangent, so that's just equal to 2 root 2.